Hi everyone, thank you very much for joining me on this presentation on how IPFS works. My name is Gino Osahon and I am a developer relations engineer. You can connect with me on these social medias using the handles. I'm on Twitter, I'm on GitHub, I'm also on LinkedIn. And so what I've done is that for each of the slides that I've created, I've embedded a QR code that you can scan to get the content of that slide. Then we also have the IPFS Discord channel, how you can join the IPFS Discord channel. You can use the discord.com/invite.ipfs to be part of the community. I have been able to put some resources that I used in creating this presentation. Okay, you can check out the YouTube video on how IPFS work. This was created by some amazing people at the IPFS team. And you can also check out the IPFS documentation website using the URLs provided there. Then IPLD documentation website and IPNS documentation website. Feel free to just scan the QR code and you have access to these URLs. So before we go into the processes or phases of how IPFS works, it would be good for you to have basic understanding of the following concepts. Peer-to-peer, what's a peer-to-peer network? You should be able to know that. Then you should know what's a decentralized network, distributed network, then the concepts of hashing and linked data structures. So what we're going to cover in this presentation, it's in 4 phases. Okay, we're going to cover how to import files to IPFS, name files on IPFS, find files on IPFS, and also fetch files on IPFS. As you can see, for each of these phases, we have some tools and protocols that are used to implement a particular phase. So for example, in the import phase, we are going to be looking at chunking, UnisFX, IPLD. Okay. So let's proceed. So before we dive into each of the phases of how IPFS works, I would like to just give a basic or fundamental on how IPFS works. Okay, you also have the opportunity of doing your own research on the concept of IPFS. So IPFS uses a file sharing model like BitTorrent. I know a lot of you that are out there, you either use BitTorrent or you know about BitTorrent. But so IPFS, the concepts, like the concepts that are abstracted, so IPFS uses those kind of concepts like BitTorrent. And what IPFS does, that it allows users to host, and you host information, you can receive information, and you can share information on a peer-to-peer network. As you can see on this image over here, we're having nodes that are part of the peer-to-peer network. So computers, these are computers from around the world making the IPFS network. So let's go into the first stage, which is importing files into IPFS. So we're going to cover concepts like chunks, chunking, and blocks. We're going to cover CID, which is content identifier. We're going to cover deduplication, piece-wide, that's supposed to be piece-wise transfer, seeking, UnisFX, Merkle DAG, and IPLD. So as part of still the phase of importing files into IPFS, the first thing IPFS does when importing files is to break the files into chunks of data by using the chunking algorithm. So what happens, as you can see on this image here, let's say we have this file that you uploaded on the IPFS network. What happens is the IPFS breaks this file into chunks. Okay, so you can call them blocks. You have a particular file that's broken down into blocks. So IPFS takes the file, breaks it up into a collection of data chunks, then and these chunks are now these chunks of files are then linked together, okay, in a single graph format. So a content identifier is generated for each block. So what you have is that after breaking the blocks into chunks, or no, sorry, after breaking the file into chunks, these files are now linked together, okay, and a CID will be generated, and using that CID, you can access that particular file. Okay, so the root CID. So what happens is that I am going to explain in subsequent slides. Okay, but each chunk is now hashed to get the CID for that chunk, and subsequent chunks are hashed until you build that tree structure. Then you now have a root CID, and the root CID is what you can share with people so that using that CID they can access the file that you've uploaded. The root CID is then stored on multiple nodes on the IPFS network. So whenever anyone looks up that CID, they will be able to download that file from the peers that have it on the network. So the concept of chunking allows for deduplication, piecewise transfer, and seeking. Okay, I think I have a slide where we're going to look at these concepts. So, okay, so what I'm going to do is I'll go back to the previous slide and try to explain deduplication, piecewise transfer, and seeking. Okay, so for deduplication, as you can see on this image over here, we have four. So a particular file has been broken into 4 chunks or blocks. And the next step, as you can see, we now have 3. Deduplication is happening here because this green, we have 2 green blocks, and in the next step, as you can see, instead of deduplication, so what that means is that the ones that are on green are similar blocks. So what deduplication does is that it only stores one of those blocks. Then piecewise transfer. So when you are downloading files from the IPFS network, you download in such a way that you download piece by piece, and you can download this information from different pairs. So instead of downloading the whole file at once, what you do is you download piece by piece. What this helps to do is that sometimes when you are downloading files, some of the piece might be bad, or some of the pieces might be bad, and instead of downloading the whole file before now finding out that, hey, one piece is bad, with piecewise transfer, you just as you're downloading a particular piece, if there's error on that piece, it will just tell you, and you can look for other pairs to download that piece for. Then the concept of seeking is also kind of similar. You, instead of like going from one block to the other when downloading files, you can just go past some blocks that you don't need and just go for the one that you need. So let's talk about UniFFX and IPLD. IPFS takes a file, okay, breaks it up into a collection of data chunks or blocks, then generate a content identifier for each of these blocks. So what happens is that at the end, it reassembles these chunk pieces into a contiguous file through the concept of hashing. So IPFS uses hashing. Remember I told you when you upload the file, it breaks it down into blocks. So IPFS hash each of these blocks to form the parent. So in the as you can see on this image here, okay, we have a block, we have three blocks, and uh, they are hashed to get the, we call these the middle, so these are not, so these are the leaf, these are the leaf nodes, okay. So it builds this tree. I'm going to talk about the Meko DAG. This is how Meko DAG work, but I'm going to talk about it in subsequent slide. So, so what happens is that from the leaf nodes, which are the nodes that are pointing directly to the data, from the leaf nodes, you hash each of these nodes to get um, their parent nodes, and you hash those parent nodes to also get the root nodes. Okay, so and the concept, the kind of data structure for this is what we call Mako DAGs or Meko DAGs. Okay, so IPFS Unis 5 is a directed acyclic graph, which is DAG, heavily inspired by the Meko 3, which keeps chunks of data connected and is used to represent a file object. Okay, so Unis FX solves the problem of being able to connect chunks of files together to get the original file. So remember, after it's broken down, for someone to have access to it, it needs to be built back up, and the data structure that's used is the MecoDAG data structure. So a MecoDAG is a tree where hashes point to data that points to other data using hashes. So as you can see, we have Meco links pointing to data. So you have the one data pointing to another data. MecoDAGs is the data structure that IPFS uses to store files. Okay, so when you're talking about storage of files on IPFS, the data structure is actually a MecoDAG. I think I still have a slide where I'm going to focus on the concept of MecoDAG. So, but MecoDAG is like the three data structures. A lot of us that are from Web 2.0 foundations know about the three data structure, but there's a difference between the three data structures and MecoDAG in the sense that in a MecoDAG, you can have two links or Meco links pointing to the same data. So I'll be talking about IPLD. It's an acronym for Interplanetary Linked Data. Okay. It is a meta format for understanding, encoding, and decoding Meco linked data. So IPLD is an extraction of a component in IPFS. Okay. So IPFS, the infrastructure, but IPLD is what handles the underlying data structures of how files are stored. So IPLD uses hashes, which can also be called Meco linked Meco links. It uses these hashes instead of URLs. So in Web 2.0 kind of data storage and provision, you use URLs to access a particular data. But on IPFS, IPFS uses IPLD to, instead of using URLs, we use hashes in IPLD. We use hashes to connect data. Since it is using hashes, it provides immutability. So one thing about the concept of hashing is that there's immutability, because if you change a particular content, even a single bit, if you change a single bit of a particular content, a new hash will be created. Okay. So let's go to the next phase of how IPFS work, which is naming files. Remember, the first phase is how you import files, and we have just covered what happens when you import files and the data structures that are that enable that to happen. So for naming files, we are going to look at content identifiers. Yes, I've talked about content identifiers before, but we'll take a deep look at what content identifier is all about. So after gaining some insight into the internal data structure, which is the Merkle DAGs, UnisFX, IPLD, so let's learn about how we name things on the IPFS. So what happens is that after the first phase, we now have objects that are stored using IPLD concepts. Okay, we need to be able to pass them around in the network. So for this, we use CID, and CID is an acronym for content identifiers. So what are content identifiers? Content identifiers are the most fundamental concepts of IPFS architecture and are used in content addressing. Now we have IPFS is using the concept of content addressing, and Web 2.0 is using the concept of location-based addressing, where you find information based on where that information is stored. Okay, but for IPFS or Web 3.0 kind of accessing contents, we use content identifier. And the concept of content identifier is that instead of using location to generate how you can accessify, we use the hash of that particular content. Okay, so you hash the content itself, generates a CID, and people can access that content using the CID. So content addressing does not display where the file is stored. Remember, it's a peer-to-peer network. You don't have to know where the files are stored. You just need to have the identifier for that content, and you can download it from fellow peers. So what happens in how we generate content identifier is that it starts with cryptographic hash function that matches the input of an arbitrary size of data to the output of a fixed size. So you have, as you can see on this image, this is the concept of how we generate content identifiers, which are CIDs. So you have a hash function, you pass that data into the hash function, and it creates what we call hash digest, or the unique identifier. So one thing about hash functions is that it's a one-directional thing. So anytime you pass a particular content, you always get the same CID or the same hash digest, but you can't generate a content from the hash itself. So this enables us to make sure that the same data should always produce the same hash, okay, which means it is deterministic. Okay, so it also ensures uniqueness to make sure no two data can produce the same hash. Okay, so no two data can produce a particular hash. One data is going to produce a unique hash. Okay, and another thing about hashing is that you cannot get content from the hash value. So CID has two versions. We have the CID version 0 and CID version 1. I think we're going to look at how they are different from each other. So when naming files in the on IPFS, we use content addressing instead of location-based addressing. Remember, I've explained the different, what content or location-based addressing and content-based addressing is. But the thing is that there is a problem with location-based addressing. The problem is that even if the content that is located at that place is chained, the URL will still point to the chain value. I don't know, yes. So if you're using, this is a problem with location-based addressing, because you are using the location where that file is stored, but the content of that location can be chained, and that URL will still be pointing. But in content-based, whenever the content is chained, it will generate a new hash digest or CID. Okay, so um, that's one of the problems that we're having with location based, and that's why content addressing is more awesome than location addressing. So also let's look at IPNS. So IPNS is what we call the full meaning is interplanetary name service. Okay, so this is how we name files on IPFS, and so you like it, some of us would think that because we can't update a particular content, because if we do a new hash, it's going to be generated. Okay, but we also have concepts where you can update content and connect that CID that was generated, so people don't have to be using new URLs to access updated contents. Okay. So the next thing we're going to talk about is how we find files. Remember, we've gone through 3 phases, which are importing, naming, and the next concept we're going to talk about is how we actually find files on IPFS. And they include the following concepts. Okay, so we're going to talk about routing, the routing table, distributed hash tables, and Cademlia. So we use routing or content routing to find contents on IPFS. So this is how you find contents on IPFS. We start by taking the CID of a content and then use the routing system to do the work that is needed to find out the set of people on the pair network that are currently hosting that content. So a routing table is a set of rules used to decide where data traveling over a network should go. So when finding contents on IPFS, every pair maintains a routing table, and in this routing table you will be able to connect with peers who have that particular content. Okay. And we use IPFS has created a tool to handle how routing works, and the name of the tool is called Cademlia. Okay, so you use Cademlia in IPFS to implement routing. So the distributed hash table, it's a table that contains a content and the CID for that particular content. Okay, so you have peers who we have a dedicated nodes of peers that maintain the distributed hash table. They are selected. Okay, not everybody. This was done to make sure that we have nodes that will be readily available to serve data. Okay, so these pairs are selected, and so what you do is that when finding a file, you reach out to these peers who maintain the distributed hash table, and in the distributed hash table, we are connecting data to a particular CID or the peers that are close to that content. You can use the DHT to find peers who know about a particular content. The last phase of how IPFS work is fetching files. Remember, we've imported a file, we've named that file, we've named the file, then fetching the file. Now, finding the file is how you actually download content on the IPFS network. And we use the concept of bit swap. Okay, So this is how we actually fetch data on the IPFS network using BitSwap. So BitSwap is all about the fact that I send you a list of things that I want, and you send me a list of things that you want. So if you want to fetch files, you have a list of files that you want. So you look out in your pairs and ask them which of them have the files that you want, and they also can send you their want list, which contains what they also want, and you both check to see if they have. If they don't have, they point you to the next pair where you can get it. And this happen. What happens is that every time you reach out to get a file on IPFS, you are 50% closer to the content. So after that, they then swap their want list. After receiving what the other peer wants, you check to see. I've explained this concept. So once you receive your content, you need to do what we call integrity checking. You need to authenticate, because you don't even know the location of where you are fetching data from. You're just fetching data based on the content using the CID. So you need to verify that the data you have gotten is the same as what you want, and you use integrity checking. What happens is that you hash the content that you have received to see if the CID that was generated matches the CID that you use in making the request for that content. So once you get this, once you get the hash, you can. So what happens is that when a file is hosted, a hash, like I said, is generated, and you can share that hash with any of your friends or anybody who wants to access your content. And using that hash, which is like the CID, they can access that particular content. And what happens is that when they do this, they cache a local copy of that content. So anyone that wants that content can easily get it from them if they are closer to these peers who have cached your content. So one other thing is that when you do integrity checking, you are able to find out if something has changed in the content. So if maybe a hacker or somebody has gone to change the content, maybe you are looking for a particular breed of dog, and somebody else has gone to change that dog that was pointing to, that the CID was pointing to. When they change that, because of the immutability nature of the data structure, that a new CID will be generated. So one thing about content integrity is data integrity, or checking the integrity of the data you've received, that it enables you to know if the data has changed. Yes, so that is how that is a presentation of how IPFS works. You can scan this QR code to join the IPFS Discord server, and you can also scan this QR code to join the IPFS Slack community. Thank you very much. I appreciate the opportunity.